Hello, everyone, and welcome to this new LabVIEW webinar. Today, I would like to talk to you about AI in R&D and make kind of a reality check between the expectations in most companies and the reality of the technology and the current state of the art. For those who don't know who we are, maybe you're attending for the first time on one of our webinars, or you see this video for the first time. LabVIEW is a company from the Netsch Group, and the reason why you received the invitation from Netsch Analyzing and Testing is because we cooperate very closely with the marketing team, and we are very thankful for that. What is LabVIEW? LabVIEW is a software company within the Netsch Group with the goal to accelerate material innovation, to help our European industry to keep shaping the world of tomorrow and our society. And the mission is really to redefine how material innovation is done in Europe. For that, we have developed a software platform that makes your R&D data more usable, more accessible, in order to develop better products much faster, but also enable this kind of data-driven decisions instead of just gut feeling based. And there is one part of our work which is kind of a little bit different. We want to be the company who is the bridge between technology like AI, machine learning, and so on and so forth, and R&D experts. Because if you're not from the field, it's probably very difficult to keep up and follow. That's why we try to do everything we talk about is very oriented towards translating technologies into tangible, usable features, but also trying to explain as much as possible, and that's going to be the case today as well. What are the current challenges in material development? If you work in R&D, I don't think I have to tell you about it, but as a recap, we have identified, it's kind of an ongoing survey with our customers. We have identified 4 main challenges, especially in Europe, in material development, material R&D. The first one being a very high pressure to be more innovative, I would say. Talking about the outside world, you have new competitors coming from anywhere, Asia, India, any countries, any region of the world. The world is more global. They are somehow also very fast, or much faster than they used to. But if you look at Europe, we have a lot of regulations, and these regulations and constant changes, they actually put us under pressure to be more innovative and more reactive. And a third component would be the customer expectations. Of course, customer want more performance, cheaper, and much faster. So all that is one of the challenge. Another very big challenge that has been confirmed over the last months and even the last weeks on different trade shows. There is a whole generation shift in the R&D department. What does it mean? There is a generation retiring, which is not a surprise. Every generation retires at some point. But the baby boomer generation, let's call them like this, they are the carriers of a very deep knowledge because they are the last generation who actually worked mostly before Microsoft Excel was introduced. What does it mean? It means that when they retire, the company loses the experience and the knowledge. On the one hand, it loses in its investment if the person has been working his entire career within the company. On the other hand, you probably have this phase, your one colleague you always ask questions to. Imagine this colleague is not there anymore. Well, that's going to be a little bit more difficult to work, right? A third challenge will be the data. The data is completely scattered. You have different sources, different type of information. Forget about Excel sheets, which is the daily tool, but you also have more and more systems. You have an ERP system. Maybe you have a system somewhere else in the production or in your technical center. Some companies even have a specific software for the management of the materials, the data sheets. You have Microsoft Excel, maybe you use Microsoft Copilot. You also have different external sources, maybe from scientific papers, and so on and so forth. It's a lot, and the data is basically everywhere, which means it's somehow also nowhere. And that's why we don't have time anymore to reinvent the wheel, which is what we do. 50% roughly of the projects you do in the R&D are actually based, or projects regarding previous formulations and or results that you have done in the past. You just don't know about it anymore. Another observation, and maybe even an explanation, if you will, for these challenges. The first one is this logo here. This traditional, typical Excel-based R&D just doesn't work anymore. And I think there is no discussion to have about it. It's for sure. Excel cannot cope with different information sources. Excel is meant to enter data manually, so it's not meant to be more efficient because you cannot connect any sources to your Excel files. Excel is also not providing any very consistent file structure, to be honest. You can build templates, but you cannot really protect the templates forever. It's always possible to change the structure of the template. Excel doesn't search through the history. So if you have 1,000 Excel sheets or Excel files in a folder, you cannot search through it. Whether Excel or Microsoft Copilot or Windows, they don't allow for a good and deep search. And at the end, working with Excel means that you probably lose 45 to 60 minutes a day searching for information concerning projects or specific result, a sample, or a customer request. Another observation, there are some expectations towards AI when you look at R&D teams and R&D leaders. The first one being AI should support analysis of data, for example, select and summarize projects or experiments or test results. Trend analysis as well, support by the understanding and exploration and use of other documents. I don't know, old project reports or technical or safety data sheets and so on. And finally, the predictions. Prediction is probably the biggest trend here and the biggest expectation. If we had to rank them, I would say prediction is the highest right now, because everyone understood that once you have data, using AI is kind of the new natural thing to do. But lastly, another observation. Many companies, I just had a call with another in Germany, they all try to develop some kind of AI use cases, but they don't improve the data foundation. So I'm taking my current data, which is a little bit garbage, and I'm trying to do an AI project or buy a proof of concept. It doesn't work, and then the result is, because we're all a little bit skeptical, it's because of AI, not because of the data. Well, the truth is that 50% of these generative AI projects fail for a couple of reasons. One reason, data is not ready, because the data quality is basically bad. So I have data everywhere, and I think you've heard that before, because it was true since the early days of digitalization: garbage in, garbage out. That's a fundamental principle of any AI project. A poor data base leads to poor insights or poor results. Data silos, if you don't bring your data together, it's not going to work either. Whether you could talk about different persons or departments, if you have different sources and they're not integrated, while any type of AI model, large language model whatsoever, will not obtain the full and complete picture and be able to work. And there is a lack of governance, because if you don't have any clear responsibilities, while these inconsistencies and errors are going to keep occurring frequently, or even more frequently maybe, and it's going to reduce over time the reliability of AI results. So here, maybe your first takeaway for you: if you want to go into AI projects for your R&D, just don't ignore the data. Think about the data first and then start projects. Our solution, our approach is called material intelligence. We think that if you combine data, processes, and intelligence in one central place somewhere, you're going to bring the full power. And we're talking about data here, every data. So from raw materials up to formulation, processing, test standards, and also measurement results from the lab, every single thing in one central database. Then you combine it with your daily workflows. It could be some project management, task management. It could be the management of the resources, for example, the raw materials or the samples, and also a little bit of lab management, very tiny bit, adjusted or adapted to the R&D. And on top of that, as a third layer, you bring some intelligence. Talking here about generative AI, but also about predictions and very recently R&D agents. Combining these three layers is basically what we call material intelligence, or bringing more intelligence around your materials and material development. We have translated that into a platform. That's a software, so it's a database software where all the data is structured and harmonized. And I want to talk a little bit more about this AI layer, because the workflows, we've been talking about it. You can see it on our website, on our YouTube channel. It's different menus, and it would be almost a demo. That's not the point for today. Today is the point of what's the reality when we talk about AI, and maybe do this kind of reality check, right? So currently, the meaning of AI with our software solution, our material intelligence platform, is called Auto. Auto is an AI-powered assistant which understands all your data, which means you have some interface, you can have a conversation with, usually as a chat, and in the background you have one LLM, so one large language model. For example, ChatGPT could be another one. It could be Gemini, it could be Mistral, it could be Llama, any type of LLM. You have access, or this LLM has access to your data, so it's a database and not the internet, it's the database. And this LLM is, as the single tool or the single entity, has to use tools. And the tools can be translated into skills or competencies. The first one being be able to search. So quickly search through the database and find results, for example, a starting point for a project. Document search, I could have a SharePoint folder somewhere and give access to my assistant, and the assistant will be able to extract information and do summaries from these documents. Data analysis is basically what you know from Excel with mathematical operations, everything, any type of calculation, and also visualization is possible. Documentation means it could support me to write down a report, summarize a project, summarize experiments, and so on. So a little bit of, a quicker way to make documentation. And finally, the predictions would be also possible, for example, AI-based experiment design. Now, I'm talking about here one LLM, so one assistant doing all of this. But here's the reality. This year is actually, for us and for many software companies, the year of the transformation. Why? Because if you're honest, technologies, especially AI technologies, are evolving so much faster than they can be. They're able to be implemented in the wider, at scale, the wider mass. So imagine for you as an R&D expert, or your team in the R&D, you don't have maybe someone who is a specialist in AI. And if you're not a specialist, it's very, very hard to cope with the development of technologies, which is why I thought for today it would be interesting to basically give you an overview of this current state of the technologies and what does it mean, the transformation. It sounds very critical, but it's actually a big change, because if you look at, first step of the transformation, let's look back a little bit. 2024, we were the first company introducing, in Europe at least, the first AI assistant for the lab. So our Auto, right? Able to answer simple questions and execute simple tasks. And what we call the tool calls is basically you have one interface and one large language model, so one assistant. And this assistant would be like if you ask the assistant to be able to build the entire house alone. It has to be an electrician, a plumber. It has to be able to build the foundation, do the garden, the roofing, and so on and so forth. Then, end of 2024, beginning of 2025, some new technologies for these AI infrastructures starting to emerge. And we didn't hear so much about it as consumers because it's very complex, and here is just names of it. So like if you're interested, you can search about it and have a Google search or whatever. Let ChatGPT explain you what it is. We're talking about reasoning technologies. Maybe you've seen on ChatGPT that it was called at some point a reasoning model. So it's a thinking. I think many tools like Gemini, they say like the tool is thinking. There is something called MCP, or communication agent to agent. We're going to talk about that very quickly. Some skills and the memory layer. So just to give you an overview, it's very sound like buzzwords and weird technologies, but these were emerging last year, and they kind of mature to a point where now it's actually usable for companies like us, companies like you as well. So for more at scale, let's say, it's not only reserved for super high-tech companies from Silicon Valley, I would say. What does it mean? This year, we are implementing or rebuilding our AI assistant into an agent system. And we call that the co-engineer or co-chemist. Could work as well. What does it mean? It's a system instead of an assistant, able to handle complex or more complex requests with some of the technologies here. It's different agents, so it's a system. It's not one single tool. It's an agent system, and it has a memory layer as well to actively use the knowledge in the database. And this I want to show you today as a second step. What does it mean? What's this huge transformation? And that's for me the real reality check. That's the reality of today, AI in the R&D. What is possible? What is happening right now? What can you buy if you're interested? That's what is available in Levy. We're not specialists here, so let me try in simple words to describe the difference between an AI assistant and an agent system. The AI assistant, you can see here on the left side, you have a question, you have one LLM assistant with different tools and has to build the entire house. The multi-agent system works a little bit differently. You have an interface for the user, and then you have a whole organization of AI tools behind it. And that's the real difference here. I think I prefer this one, this definition here. So if we start on the left, I have a user request. So I'm asking a question about searching and calculating something. And this question goes to a supervisor agent. That's basically the agent that is taking your question in. It's breaking down the whole request into individual tasks. And it's sending the task to specialized agent. You can see here in the middle. A specialized agent could be, for example, an agent only doing data search in the database, or an agent doing only mathematical operations, or an agent doing only the visualization. And what happens here is basically if you have a question where you want to search something, calculate the result, maybe an average, and put the results on a diagram. Well, now the first task is done by the search agent. The search agent is searching for the results, sending its results to the calculation agent. The calculation makes the calculation of the average, and the average result goes further to the visualization agent. This one is building the diagram, creating that, and the whole package is going back to this safeguard agent as a quality gate, if you will, and then going back to me as an answer as a user. So that's basically how we work as human beings as well. If you think about it, it's kind of the organization of our departments within the company, just with technologies. There is a difference. So why do we think that it's the right transformation right now, and why do we follow that? Again, reality check. The AI assistant on the left side, we compare the results for easy, medium, and complex requests, and try to do a kind of a benchmark, if you will. So as you can see here, you have always on the top the agent system, so the new structure, and assistant is the old or current one. And then you have three colors. Green is passing the request, finding an answer. Yellow is asking for help, meaning I'm not sure or I need more information, and red is failing. And as you can see here, basically The agent is correct right at the first attempt in 82% of the cases and only 27% for the assistant. And for complex requests, the agent has almost zero failure rate, which means when the agent system doesn't know, it's asking for help, so asking questions to come further, where the assistant has a 100% failure rate, usually is more or less going to try to find an answer that doesn't exist. And it's more efficient. It's also something that is interesting, by the way, reality check. It can be very, very costly to just do LLM and then use tokens and tokens every day. The AI assistant requires help much more frequently, which means more interaction, more questions and answers, so more consumption of AI computing power, whereas the agent is requiring help more rarely in 98% of the cases. So it's much more efficient, and at the end, it's also cheaper. So another step of the transformation, the step one was going to from this assistant to the agent system. And the step two is bringing in the whole prediction topic, because we've seen it's one of the four expectations and probably the most important one right now. Now, there is a thing, it's called machine learning. We have talked about it in previous webinars and videos. If you're interested in that, we tried to explain that last year. There is a challenge with machine learning. Machine learning is basically using your data, training algorithm, and trying to make predictions. But the reality is it's not very efficient. You need a lot of data, first of all. So if you're a small or medium organization, it's probably not going to be very good. And 80% of the time, hence 80% of the budget you spend on a machine learning project, is spent on data preparation. You have to clean the data, you have to standardize the data as well, to structure, for example, formulations, the process parameters as well. You have to go through the data and make sure that it's complete and accurate. You have to extract some information like descriptors for material and components. So which data is used to describe a material, for example, and so on and so forth, up to basically creating the final training data set. And the remaining 20% are it's the actual machine learning work. So training, fine-tuning the models, selecting the features, evaluating the results and the performance, and then updating iteratively the model, right? So now think about it. If it costs $100,000 or euro, you spend 80,000 basically on preparing data and only 20 on doing machine learning. It's not efficient, which means we don't think that it's the right approach. And forget about the data amount. Just this is not the right approach for the typical European company, which is not a multinational organization. So here, a different view on what's possible. There are some new technologies that work, and you can see here on the left side, one is called Bayesian optimization, but it's not the only one. But basically, to summarize it, we think the right approach is here to use machine learning guided experiment selection. Some call it design of experiment, but design of experiment is actually only based on statistics. So I would personally call it AI-based design of experiment. Machine learning guided experiment selection is basically the same, but a huge difference. Compared to machine learning, it works with a more limited data set or amount of data. And the result is basically a recommendation of the most promising experiments to reach a specific target, but always continuously improving and integrating new results. So constantly updating the model. It's more efficient because you can explore your design space for experiments a little bit better. It's more suitable for companies with smaller data sets, so smaller amounts of data. And it's more efficient in terms of costs and time as well, because I was talking about the cost of a machine learning project before, but you can think of here, how is it if you save 50% of your experiments in the lab? You're talking about time spent lab, you're talking about cost of raw materials and lab hours basically. So every single parameter here is getting reduced and used more efficiently. How does it work? Well, basically it works like this. I define my target parameters. I want a specific value, a minimum maximum range of pH, viscosity, whatsoever. I do have to select the materials I want. Maybe there are some materials I'm not allowed to use, right? You can think about the PFAS regulation right now in Europe is a good example. Or maybe my supplier is not doesn't exist anymore. I don't have the material anymore. Then you can define your design parameters. For example, the formulation has to have at least 10% of water or in this direction. And the fourth point would be defining constraints. It could be a constraints like my formulation cannot be more than 5 euros per kilo. So you basically, from the test parameters to the whole design system, you define where we should move on the prediction. Like what's the playground, what's the field of action here? Then there is an AI-driven experiment planner. It's basically an AI-based model. But that's the interesting part. It's based on your historical data because the question comes very often. Where's the data coming from? Well, it's your data, your database. That's LabVIEW. That's why we do that. The AI tool learns from your own data. So every new experiment is new knowledge. It's understanding also the relationships between the different elements, for different raw materials, formulations, the sample, the test results. There is a connection between every single entry in the database. Because you define a design space and parameters and constraints, it can evaluate that and evaluate where to work and how to use it. And at the end, select basically the most promising new experiment and then suggesting you. But the loop is not done yet because you get a list of AI generated experiments with a formulation, process parameters, predictions of target outcomes, and also confidence index. And then you go to the lab, you run the experiment, you document the results, and you see how good the prediction was. If the prediction was close and you are satisfied, then you can just basically either close the project and then release the product. But if the prediction of the outcome or the outcome was not where you want, you basically go back to the entry point and it's new historical data. So it's another iteration and the system is going to learn from it and make you a better suggestion. So that's how it works. We think that's the more efficient way. Now, if I show you quickly how it works, I didn't want to do a demo today, so here's a short video. It's just 1 minute. You can see here, I'm in a project. I have project details with some targets. I define some test parameters with minimum, maximum on the right side. For example, here the pH 10.2 and 10.7, or the viscosity. You know, I can basically select it. My design parameters here with different materials, components, some formulation constraints with required additive 7 0.35 and some system constraints with pH range or price or whatsoever. And when you go into it, you can see the different formulations or experiments I did. So it's my current work. I had a formulation, a very long one, very complex one, and I did some measurements already. And that's the base, the working base for the system. The system is going to say, oh, we had results already, perfect. And basically, if I go then to the prediction side, you're going to be able to see how I can add new so-called AI experiments. And here's the list of experiments. I can add all of them. And they come here different color in green here. And you can see at the end the confidence. And then it's basically your template, your canvas to go to lab, right? So here's going to give you basically some predicting outcomes, and you can go to the lab and see if the outcome is correct or not. Just to give you an idea of how it will work in our software. Now, what does it mean to be very, very specific? If we go for AI-supported machine learning guided experiment selection, much more efficient. We've talked about it, reducing the cost and time. But here on the left side, you see a graphic. It's kind of a benchmarking between design of experiment. That would be this single point here. Random would be try and error, typical ways of working today. And the blue line would be this machine learning guided experiment selection, in this case, Bayesian optimization. The red line is the best value, so best cumulative measurement value you can achieve, and you can see here design of experiment is pretty good, but it takes 150 experiments. Humans are not that great. They usually stop after 60 experiments, or with 60 experiments, I've reached roughly half of the value compared to design of experiment. And the interesting part is the blue line here. You can see the difference here, the steps. I have less steps at the beginning, so my jump is with less experiments, I can have already a better result. And the optimum is twice as high as the human beings, higher than DOE, and it takes roughly the same amount of experiments as human beings. So you can see here, the benchmark is saying you can develop better solutions quicker with fewer experiments and make more reliable data-driven decisions, which means you can have a shorter time to market cycle as well. What does it mean if you bring this into our solution, the entire solution, a database to make day-to-day operations, I would call it more efficient, data-driven, and so on, combined to AI predictions for experiments? Well, in total, you reduce your iterations by 30% because you have just having access to your data is reducing it, but you have access to everything. You save 50% of the whole manual documentation effort, generating a report, documenting measurement results with modern lab equipment. These are completely eliminated because the system is doing it for you. And then because you can search your data, use your data, but also make predictions, you spend less time searching for what you've done before. It's more accessible. And this is roughly from this 1 hour per day, 2/3 that can be saved depending on the industry and the size of the organization. That's it overall for my reality check between reality and expectations regarding AI. So what did we see? First, you need a database. Without good data, nothing's going to happen. Second, the technologies are evolving very fast. And now we're talking about agent systems more than a simple AI assistant. Third, machine learning is not always the best solution. There are different approaches behind machine learning, and AI-based design of experiment is one of them and probably the most promising right now. I think these are the key takeaways for today. If you have any questions, don't hesitate to let me know. You can use the Q&A function here. If not, I will be able to answer the questions afterward per email.